In Part 1 of Lecture 10, we will discuss encryption and authentication. Encryption goes back to the days of Julius Caesar. If you need to send a written message to one of your generals, you need to make sure that it isn't intercepted. It could cost you the battle or even the war. One of the earliest codes in history was a simple substitution code that Julius Caesar used. Take a piece of paper and write down the page the letters A through M. Opposite the A, write N. Opposite B, write O. And so on down the page until you've written Z opposite M. Then you substitute whatever letters you have with the letter opposite it. This would change hello into URYYB. It looks like nonsense unless you have the key. Unfortunately, that code was broken a long time ago. Nowadays, we have more sophisticated codes, but they all work on the idea that each character is replaced by something. The original text that you have is called plain text or clear text. What you encrypt it into is called the ciphertext. The process of changing plain text into ciphertext is called encryption. Reversing this and converting ciphertext to plain text is called decryption. Modern codes are complex because if they weren't, modern computers could break them very easily. They require an algorithm, a procedure for the computer to follow, and a key. The key is a word, a number, or a phrase that we need to do encryption, decryption, or probably both. There are many techniques that can be used for encryption, and some are better than others. Currently, the world standard is AES, or Advanced Encryption Standard. As computers get faster and more powerful, I am certain that these encryption algorithms and keys will be retired, and newer ones will replace them. Newer versions of Microsoft Word allow you to encrypt your work. This shows you how important encryption is becoming. Authentication is making sure that you are dealing with the real thing. In our case, we want to make sure that the person with whom we are dealing is who he says he is. The most common ways of doing this are passwords, personal identification numbers or PINs, fingerprint scans, and more recently, even facial recognition. These are our main defenses against those who would steal data and invade our privacy. Both iPhones and iPads can be configured to require a login passcode, which is a password that is usually 4 digits long. Android devices work differently. There are a large number of security settings that one can use. It is important to note that Android devices do not automatically encrypt data stored on the device when a user activates the login password. Similarly, on Android devices, configuring a password and activating encryption are two separate steps. You are looking at two different settings screens on an iPhone. The screen on the left shows a device that requires a passcode and that has its data encrypted. There is an option that allows strong passcodes, which can be 8 to 14 digits. Full strength requires using numbers, letters, and symbols. The screen on the right shows what a user can do to tighten security further. Turning off Siri, the digital assistant on iPhones, would be the first step. Having it erase data after the 10th failed login would be the logical next step. Windows offers several password options that can be configured using the Accounts utility. You can access this from the Start menu or the Control panel. Windows devices can be encrypted using BitLocker from Microsoft or third-party software. Macs offer a way for people to log in without a password.